This assessment asks us to tell which side of the equilibrium is favored by delta H, delta G, and delta S. Let's start with delta S. If we notice, this reaction is two molecules going to one molecule. And so the product side is going to be less disordered. That means that delta S for this reaction is less than 0, implying that entropy favors the left side of the reaction. In order to know what delta G is, we have to know what delta H would be. And so let's do that calculation. We can do that by looking at the bonds formed and bonds broken in the reaction. So the bonds that we're going to break an OH sigma bond. That energy is 119 kilocalories per mole. We're also going to break a carbon-carbon pi bond. So 65 kilocalories per mole. In terms of the bonds that we're going to form a tertiary CO sigma bond, the energy of which is 91 kilocalories per mole. And finally, we're going to form a carbon-hydrogen sigma bond at the secondary carbon, a value of 95 kilocalories per mole. If we do the math, what you notice is we have a total of 184 kilocalories of energy that we have to put in to break the bonds. We're going to get back a total of 186 kilocalories for the bonds that we form. 184 minus 186 gives us a value of -2 kilocalories per mole as our value of delta H. With a delta S that we know that's less than 0 and a delta H that we know is -2, by the way, the -2 delta H is going to imply that the right side is favored. So entropy favors the left, enthalpy favors the right. What about delta G? Well, if we think about delta G, we know it equals delta H minus T delta S. And this is a case where we have a delta S and delta H that are opposing each other. Delta S favors the left, delta H favors the right. And so the delta G is which side is favored by delta G is going to depend on the temperature. At low temperatures, that's going to make the entropy term less important, and so the reaction will be favored to the right. Whereas at high temperatures, we're going to make that entropy term more important. That's going to drive the reaction to the left, or make the left side favored. So with opposing enthalpy and entropy, it's going to be temperature dependent as far as what delta H, which side of the reaction is favored by delta H.